Hey students, this is lesson 321. In this lesson, we're going to learn how to find percent increase and decrease, which is the first objective of this lesson. In the second video, we'll learn how to interpret comparisons that use ratios and percentages. So, trying to learn how to calculate percent increase and decrease. To do that, we have to understand what it means. And these bars kind of show that. Notice that when we go from 1999 to 2006, there's an increase in the number of births. Well, if there was an increase, if there was the same number, then we would say that there's 100% of the number of births in 2006 as there were in 1999. It's that amount above this little bit here that is our percent increase, if we calculate that as a percent. So as a portion of this whole 100% here, what percent is that? And a percent decrease is similar. We look at these two bars. The active duty personnel has decreased from 1995 to 2005, and this little area right here shows the amount of decrease, and we're gonna consider that as a percent decrease when we compare that to what the original or the beginning amount of personnel was. So if we compare this empty space here to this whole bar here, what percent of that is that? So that's what we're looking for here. To do that, let's go to the third page here. And I'm going to show you two ways to do it, and you can decide which one you're the most comfortable with. So in problem number 7, it says in 1985 there were about 39,900,000 U.S. households with cable TV. In 2006, there were about 65,500,000 households that received cable TV. What is the percent increase of households with cable TV from 1985 to 2006? Okay, so what we're going to do here is we're going to look at these two numbers as a percent. So what we're talking about is what percent is 65.5 million compared to the original number 39.9 million. And if I want, I can just set this up as or 65.5 is my part, and 39.9, now I'm doing these in millions, is my whole. And then if I change that to a percent, what I get is, I get about, now I'm rounding this when I do the cross multiplication and divide, I get about 164%. What I'm saying here is that this number here is 164% of this number. Now the percent increase is only that part above 100%, or that part above where the numbers would be the same. So to get the percent increase, I just want the part above 100%, so I'm just going to subtract 100, and that gives me a 64% increase. Okay, now that's one way to solve it. The other way is to find that increase first. So to take the 65.5 million and subtract the 39.9 million first, and just find out how many more households receive cable TV. If we do it that way, we get 25.6, and now I'm going to use that number to find the percent. So I'm going to compare that number, 25.6, the increase in the number of households that have cable TV, to the original number, which is 39.9. Find the percent for that. When I do this, it is my percent increase, because I've already gotten rid of the amount of households that originally had cable. So I get a percent increase when I do this, and you'll see that if you do 25.6 times 100 and divide by 39.9, you get 64%, and that's the increase. Okay. Sometimes you have a percent decrease, and number 8 shows that. To do number 8, I'm going to use both methods again, so you can kind of compare them. So shoes are regularly priced for $55, are on sale for $41.25. What is the percent decrease from the original price, sale price? Okay, well, if I set up this proportion like this, if I use 4125 as the part, 55 as the whole, and find that answer, so I cross multiply and divide and take 41.25 times 100, divide that by 55, I end up with 75%. And what that's saying is that this price here, 41.25, is 75% of 55. So the sale price is 75% of the original price. The decrease is actually how much I'm getting off of the original price. If we think of the original price as 100% and I'm paying 75%, then my discount is the difference between those, or 25% decrease. So in this case, I have to subtract that amount from 100. Now, that's sometimes confusing for students, so I kind of like this way better. Since we want to know the percent decrease, why don't I find the decrease from $55 to $41.25 by just subtracting them. So I subtract those and find out how much my discount is. How much am I getting off? When I do that, I get $13.75. Now what I'm going to do is compare that to the original price of the shoes as a percent and find that. So now I'm going to take 13.75 times 100 divided by 55. So when I do that, I get a decrease right away. So the 25% decrease. All right. Okay, let's do one more problem. It says the average hourly wage in the United States was $9.02 in 1997. It was $12.29, and in 2007 it was $17.10. And the first problem is saying, what is the percent change of the hourly wage from 1987 to 1997? So in 1987, it was $9.02. In 1997, it was $12.29. So it went up in price. So we're looking at a percent increase here. I think I'm going to do it this way. I'm going to do the method where you first find the increase. So how much is this going up by? So I'm going to do 1229 minus 902. And that comes out to 327. So the wages went up $3.27. Now I'm going to compare that to where the wages were, the original wage, which is a beginning wage, 1987 wage, and change that to a percent. And I get 3.27 times 100 divided by 9.02 equals about, and I'm rounding this, about 36%. And since this number represents the difference between these two, that's the percent increase. All right, I'm going to leave one more problem for you to do, and then we'll talk about it next time we meet in class. But use one of the two methods that I did to see if you can figure out what is the percent increase in hourly wage from 1997 to 2007. All right, I'll see you later.